Once again, good morning everyone. I would invite Himanshu sir to start the session.
Good morning, everyone. I'm sharing my screen with you. Is this visible?
Yes, sir.
Okay.
Yes, sir.
So we'll start one thing. We'll start the basics of chemical bonding today. Okay. So can anyone tell me why there is a need of chemical bonding? Why all the elements are making bond? Any reason? Okay, let me tell you. See,
Sir, to become stable.
to become stable. So if any of the element is doing bonding just to become this stable, so what are the criteria for this stability? We have two rules. What are those?
Drafted rule.
And first one is duplet rule and second one is octet rule. Duplet means to complete the two electron in the outermost shell, and this rule is only applicable for the hydrogen and helium. While for the other elements, octet rule is applicable. And why for only hydrogen and helium? Just because they have two electrons in the outermost shell. So you have taken earlier two classes of chemical bonding. So can you please tell me what is the type of bonding you have learned? Anyone? Type of bonding? Okay.
Ionic bond, covalent bond.
Sir, ionic bond and covalent bond.
Okay. So we'll introduce third type, that is coordinate bond right now. Okay. So today I'm not going to go that much deep in the bonding. First, I'll explain the basics of ionic bond, covalent bond, coordinate bond. So bonding, whenever I'm talking about the bonding only occur by either transfer of electron, or you can say by sharing of electron. Very good. Sharing of electron. So if I'm talking about the transfer of electron, so for that is metal to non-metal transfer. When a metal is donating its electron towards the non-metal. And in this transfer of electron, the bonding we learn, that is ionic bonding. But if I talk about the sharing of electron is of two ways again. One is by mutual sharing of the electron when two of these species are giving equal electron. For example, A and B. A is also sharing its electron, B is also sharing its electron, and equally they both are contributing in formation of bond. So if they are forming bond by mutual sharing of the electron, the type of bond is known as covalent bond. While if there is no mutual sharing of electron, if there is no mutual sharing of electron, it means there is sharing, but one will be electron rich species, another will be electron deficient, you can say. Or electron deficient, if you don't want to say electron deficient, you can say that that species must contain the empty orbitals. I'll talk about the orbitals later, but it must contain the space for the electron. So there is a sharing of electron, mutual sharing and no mutual sharing. And if I'm talking about the no mutual sharing, it means I'm talking about the coordinate bond. Okay. This much is clear for you?
Sure.
Okay. So bonding again, transfer of electron or by sharing of electron. Transfer will say metal to non-metal. It will form ionic bonding. Well, if I'll say sharing of electron again, mutual or no mutual, mutual, it means we are talking about the covalent bond. No mutual sharing, we are talking about the coordinate bond. Okay. So let's start with ionic bonding. Ionic bonding. See, can anyone tell me what is the another name of ionic bonding? Okay, it is also known as electrovalent bond. Or sometimes we can also say it as electrostatic bond. Okay, so in ionic bonding, what we learn that there is a transfer of electron, and from where to where? From metal to non-metal. So if I talk about again metals, metals have the great tendency to donate electron. Why they have the great tendency to donate electron? They can easily donate electron instead of accepting. I'm talking about they can easily donate the electron. Why? You have learned a periodic table chapter. So can you please tell me why there's a reason that metal donate electron easily?
Valence is
Valence is
unstable.
Valence
1
shell
to
is
4, sir.
valence shell is unstable, you can say. Or second thing, if I'll say the atomic size of metals, don't you think that atomic size of metal is quite bigger as compared to the non-metals?
Yes, sir.
है ना?
Yes, sir.
So same thing, this is nucleus, this is one shell, this is another shell, this is another shell. And second, I'm comparing this nucleus. Electron is here in both of the atom. So this is A, this is B. Can you tell me from A and B, which one is easier to remove? Which atom can easily remove the electron very easily? A or B?
B, sir.
BB.
B.
B. Why B?
Because the orbit also is
Sir,
far away
atomic
from the
radius
nucleus.
is
See, number of shell
bigger.
is same. Number of shell is same, but the effective charge felt by this particular electron and this particular electron is different. Just because here the atomic size is big, so electron can easily be removed. But in case of this atom, electron cannot be easily removed just because this is more close to the nucleus and it was feeling more effective nuclear charge. Clear?
Yes, sir.
Okay. So if the metal is donating electron just because incomplete shell, second thing, the atomic size is quite big, so it can easily remove the electron. So in case of that, they can easily form the cation. What is cation?
Positive ion.
Plus
Positive
charge.
plus charge. For example, I'm talking about NaCl. Just a basic example. I'm talking about sodium. What is the atomic number of sodium? That is 11.
11.
minus
2, 8, 1. So it have one electron extra in its outermost shell. So if it will donate one electron from the outermost shell, it will become Na positive. This is a cation. Second thing, Cl have atomic number 17.
17.
It will accept electron just because it have 7 electron in the outermost shell. If it will get one electron, it will get satisfied by the octet tool. So it will accept this one electron and it will become Cl negative. So now we have learned one thing, that the positive charge always attract the negative charge. So what this attraction is known as? Do anyone know? What is this attraction? This attraction is known as electrostatic force of attraction. Just note it down somewhere so that you can remember that whenever there is an attraction between the positive ion and the negative ion, that is known as electrostatic force of attraction in the ionic bond. So why Cl is accepting the electron? As we have talked about the metal
Become
session.
state.
to form stable. So
Yeah. See, 7 electron in the outermost shell, it will get one electron. So easily it will get the configuration of noble gases. Okay. Second thing, you can say that atomic size of atomic radii of this chlorine atom, that is 2 electrons in the internal shell, then 8 electrons here, okay, and then again 7 electrons on the outermost shell. So it have the tendency, just because the effective nuclear charge felt by the outer electrons is quite more, so it can easily attract the electron which was removed from the sodium atom. So it will easily accept the electron and become stable. Okay, if I'll go for another example, that is calcium oxide. Okay, just a basic example I'm taking right now, just because I'm clearing your all the doubts that what is ionic bonding, what is covalent bonding and all. So what is the atomic number of calcium?
20.
20. Configuration 2, 8, 8 and 2.
2.
Oxygen atomic number is 8. Configuration 2, 6. So chlorine is a metal. It have the tendency that it can easily donate its 2 electrons just because its ionization energy is more or less.
Can you
Less.
repeat once again, sir?
I said that in calcium, the 2 electrons, outermost 2 electrons, it can easily remove.
Yes, sir.
Their ionization energy is more or high. See, calcium is a metal. Metal have the great tendency to donate electron. If metal have the great tendency to donate electron, just I told you that they have a bigger atomic size as compared to the non-metals. So the electrons are not feeling that much effective charge, so they can easily remove the electron. So the ionization energy will be low. So for the metals, the ionization energy is always low. What is ionization energy? First, tell me.
Energy is required to
Remove
remove
electron from the
from
orbit of
outermost shell.
galaxy.
In
To
an
remove the
isolated, see, amount
Isolated
of
gas.
energy, this amount of energy required to remove this outermost electron in an isolated gaseous atom. Okay, so if it will donate 2 electron, it will become Ca2 positive ion. Same goes with the chlorine oxygen atom. Oxygen have 6 electrons in the outermost shell. If it will get 2 electron, it will become O2 negative. Now
Yes,
2
sir.
positive will attract the 2 negative, and which force of attraction is this?
Electro.
Electrostatic force of
electrostatic force
attraction.
of
Electrostatic force.
attraction.
Very good. Okay, next take one more example, that is MgCl2. Basic example. Magnesium atomic number is 12, 2, 8, 2. Chlorine is 17, 2, 8, 7. So it will accept, it will donate 2 electron, it will become Mg2 positive. But just if I'll take one Cl, it can accept only 1 electron, it will become
But
Cl negative.
yes,
But what about another electrons? Will take one more Cl, that is 2, 8, 7, and it will accept 1 electron, it will become Cl negative. Now this magnesium will attract this chlorine also, and magnesium will attract this chlorine also. So now the compound from that compound is known as what? MgCl2, that is called magnesium chloride.
chloride.
Attraction, just remember the name of attraction. Okay, we'll go more deeper into this ionic bonding later, but I was just clearing that what is ionic bonding, what is the donation of electron, why metals are donating the electron very easily, what is the force of attraction we are talking about. We have taken the certain examples of this ionic bonding. Okay, so till now, if anyone want to ask anything, you can ask whatever I taught right now. I'll go for covalent bond then. Any doubts?
No, sir.
Okay, let me ask one question. First question is just a basic question. Is there is electronegative difference? Electronegative difference between the metal and non-metal?
Yes, sir.
Yes. Which one is more electronegative?
Chlorine.
Chlorine. Why? Just because
Sir,
chlorine was
non-metal.
non-metals, just because they are I was taking the example of chlorine. So chlorine is coming in the 17th group, and 17th group is known as halogens. And halogens are a highly reactive element and highly electronegative element. So one condition is for the ionic bond, that is there must be a high electronegative difference between the species, that metal and non-metal. If I'm taking metal and non-metal, must have a high electronegative difference. Okay. Okay, let's talk about the covalent. Okay, what is covalent bond? It's a mutual or not mutual?
Bond.
It is a
Some
Share the
mutual,
electrons.
sir.
yeah, it
Mutual.
is the mutual sharing of electron. And mutual sharing of electron, I'm talking about between right now, I'm talking about the non-metal and non-metal. Metal and non-metal and non-metal. So if I'm talking about the mutual sharing of electron between the non-metal and non-metal, just remember I'm talking about the covalent bond. Okay. So what you have to do in this particular covalent bonding, you have to take the outermost electron of, you have to show the outermost electron of each species. Okay, let me take a basic example. Hydrogen. What is the atomic number of hydrogen? 1. It have only one electron in its valence shell. I'll take another hydrogen atom. It have only one electron in the outermost shell. See, both hydrogen have one electron in the outermost shell. If this hydrogen will share one electron from another hydrogen, now this first number hydrogen will have 2 electrons in the outermost shell. Now it becomes stable. By which rule? Duplet or octet?
Duplet rule.
Duplet rule. Just because 2 electron system is applicable for hydrogen and helium. Again, if this hydrogen will share this electron from this particular atom, so this hydrogen will again share atom, and they both share one electron. So there's a mutual sharing, that each of the atom of hydrogen was sharing electron with one another. So there's a mutual sharing. So on the basis of sharing, I'm dividing the type of covalent bond, that is on the basis of sharing. Okay, that is single covalent bond, double covalent bond, and triple covalent bond. What is single covalent bond? That sharing of one electron. That sharing of one electron, that it will form single covalent bond. Sharing of 2 electron, that is double covalent bond. Sharing of 3 electron, that is triple covalent bond. First classification is that share on the basis of number of electrons shared. Second classification on the basis of polarity. On the basis of polarity, I'm dividing it into 2 categories. The first one is the polar covalent bond. Second one is the non-polar covalent bond. Polar and non-polar covalent bond. So I'll discuss the examples of all these types for single bond, double bond, triple bond, polar covalent bond, non-polar covalent bond. So just take the example of this hydrogen atom. Which type of bonding is this? Single, double, triple?
Single.
Just because they both are sharing one electron, so it will be H single bond H, or you can say H2 molecule. Okay. Okay, I'll take second example, that is of chlorine. What is the atomic number chlorine?
17.
17.
287. So it means it has 7 electrons in the outermost shell. So if I'll take 2Cl atom, and I'll show the 7 electron in the outermost shell, this chlorine will share 1 electron with this chlorine, and another, there's a mutual sharing, so it will share one electron. So again, it's an example of single covalent bond. Okay. Let's take a third example of nitrogen. Basic example I'm taking right now. Okay. Third example is of nitrogen. Nitrogen atomic number is
7.
7. The configuration will be 2, 5. So if nitrogen have 5 electron in outermost shell, how many electron it require?
3.
3 electrons. So this nitrogen will share 3 electron from this nitrogen, another from this nitrogen. So it will form N triple bond N, or you can say N2. So it is example of triple covalent bond. Fourth example, I'm taking of oxygen. Oxygen atomic number 8, 2, 6 will show 6 electron in the outermost shell. So this oxygen will share 2 electron from another oxygen, and same goes with the second oxygen. It will be O double bond O, or you can say O2. So now this is example of
Double bond.
covalent bond.
double covalent bond. So main thing is, see, single covalent, double covalent, triple covalent, they can easily be classified on the basis of number of electrons shared. And the number of electrons shared between the two atoms is known as its covalency. Known as its covalency. Okay. I'll take another example of NH3. See, earlier I was doing the example of both atom in which both atoms are same with the equal negativities. Okay, before that ammonia, I will take example of HCl. That one is good. Okay, hydrogen have outermost 1 electron. Chlorine has outermost 7 electron. So hydrogen will share 1 electron with the chlorine, and chlorine will share 1 electron with the hydrogen. So it will be H single bond Cl. So which type of bond is this? Is polar or non-polar?
Covalent to
Polar. Polar
Polar.
covalent bond.
Polar. Why polar? Just because if I talk about this HCl molecule, chlorine is more electronegative. Chlorine is more electronegative, so it will acquire the partial negative character, and hydrogen will acquire the partial positive character. So it will form a dipolar ion of positive and negative. So that's why I'm saying it as a polar covalent bond. Same if I'll talk about ammonia. Nitrogen have 5 electron in the outermost shell. Hydrogen have 1 electron, hydrogen have another electron, hydrogen have another electron. So 1 electron it will share with the hydrogen, and when the hydrogen was sharing the electron, same time the nitrogen will share 1 electron from each hydrogen atom and will form NH3. But if I talk about these 2 electrons, what is the name of these 2 electrons? They are known as lone pairs. Okay. See, the electron which are not participating in the bonding. See, this electron, this electron, this electron, this electron, these 6 electrons were participating in the bonding. But if I talk about these 2 electrons which are present in that at the top of this nitrogen atom, they were not taking part in the bonding. So they are known as what? They are known as lone pairs.
lone pair.
Clear?
Yes, sir.
Okay. So is this ammonia molecule is polar or non-polar? See, there is a difference between electronegativity difference between the nitrogen and the hydrogen. That's why this is again a polar covalent compound.
Sir, can you
Okay.
say how to identify polar or non-polar?
See, identification of polar and non-polar is totally dependent upon the electronegative difference. Electronegative difference. For example, if I'm talking about, I was talking about the HCl now. So Cl was more electronegative. It was coming in the group 17. If you see the electronegative value of this chlorine, it will be more as compared to the hydrogen atom. Okay. So when we'll go for the deeper into this particular covalent bond, I'll also tell the values of this electronegative elements. So that this chlorine atom is more electronegative. So what it will do? It will you can say snatching the electrons from this covalent bond towards itself. You can say it will carry all the electron towards itself. So it will be H will get the positive character while the Cl will be getting the negative character. Why I'm saying partial is because the bond is not broken right now. If it will break, it will form H positive and Cl negative. So electronegative, if electronegative difference is present, then it will form a polar covalent compound. If there is no electronegative difference, then it will form a non-polar covalent compound. Clear? What are in which block You have the highest electronegative elements.
P block,
17th.
sir.
17th group.
P block.
P block and which group?
17th
17.
group.
17 halogens. Okay. Okay. I'm taking one more example, that is CCl4 and CCl4. Okay. Carbon have 4 electron in the outermost shell. Carbon atomic number is 6. That is 2, 4. 4 electron in the outermost shell. Cl have 7 electron in the outermost shell. Another Cl, 7 electron in the outermost shell. So just tell me that which rule it is following, duplet rule, octet rule.
Octet rule.
Octet rule.
For both carbon and chlorine, we are following the octet rule. The
Yes, sir.
compound I'm forming, is this polar or non-polar?
Polar, sir. Sir.
Okay, so this is non-polar. Why? See, Cl will, the Cl is also an electronegative, this Cl is also negative, this Cl is also electronegative, this Cl is also electronegative. So when the Cl start taking the electron pair towards itself, same at that particular time, this Cl will also take. So this will cancel out this one. Same way, when this Cl will try to take electron pair towards itself, and this Cl will try to take Cl electronegative electron pair towards itself, it will cancel the movement towards both. So none of the chlorine can take the electron pair. So this compound CCl4, whether there is electronegative difference or not, but this will considered as non-polar compound. Clear? Just because, see, if I'm standing in the mid of 4 people, and every person want to like take towards them, like they want to take themselves, and they want to take myself towards themselves, and none of the people have the same, none of the people have the more power, you can say. Both this chlorine, they have equal electronegativities. So if they have equal electronegativity, it means that none of the chlorine is able to take this electron pair, so it will act like a non-polar. So same way, when I was standing in the mid, these are the 4 people and they have equal energy, so none of them can take me towards themselves. So I will be in the mid. I'll not go this side, I'll not go this side, I'll not go this side, I'll not go this side. So I will consider it as a non-polar compound. But if the condition is Cl will get more electronegative element X, and here Cl, whatever the X is, flow, it can be flowing basically. So if X is present, then there's a possibility that there's a transfer of electron, there's a, you can say, a shifting of electron towards this X, just because it is more electronegative. Clear? Why the CCl4 is non-polar? Just because all the chlorine towards itself, towards surrounding the carbon atom, that is, they all are equal electronegative. So if they are equal electronegative, none of them have the capability to take the electron pair towards itself. Let's take. Okay. Do you want to ask anything in the covalent bonding right now? Any of the example from the starting? Hydrogen, chlorine, nitrogen, oxygen, HCl, ammonia, and polar, non-polar, CCl4, CH. Okay. So what about CH4? Which type of bonding it will show? Covalent or non-covalent or ionic?
Covalent.
Covalent. And single covalent, double covalent, triple covalent?
Single, sir.
Single.
Single
Okay.
covalent.
Okay, very good. Okay, let's start with the another thing, that is coordinate. Okay, coordinate bond. Ever heard about this? Anyone know about coordinate bond?
No, sir.
No one? Okay, listen.
No, sir.
So if I talk about the coordinate or dative bond, the other name of coordinate is dative bond. For example, I'm having NH3 and I have one pair of lone pair. Okay, one lone pair is present and I'm reacting this NH3 with HCl molecule. Okay, so just because HCl is polar, when I'll break this particular molecule, it will break into H positive and Cl negative. Is this okay?
Yes, sir.
Okay, so if it will break into H positive and Cl negative, this now the hydrogen will have no electron. Just because hydrogen have only one electron in its shell, but it donated the electron and become H positive. That electron was carried out by the taken by the Cl negative. So now the hydrogen now the hydrogen don't have any electron, but it have the shell for taking the electron. Now what will happen? This nitrogen will share its own electron to the hydrogen atom. The lone pair, only the lone pair it will share that lone pair with this hydrogen atom and it will form NH4 positive plus Cl negative. Now if I talk about the representation of this coordinate bond, nitrogen, this was the structure of ammonia and we had that lone pair, but when it donated its lone pair to the hydrogen atom, we will show like this. The head part of the arrow will towards the atom on which we have we have shared the electron, and the tail part will be towards the nitrogen because that nitrogen was sharing its lone pair and it will get positive charge. So it means if I'm talking about the dative bonding, this species is considered as electron rich species and this hydrogen is considered as electron deficient species, you can say. Am I right?
Yes, sir.
Why ammonia is electron rich? Because it has the lone pair.
No. Yes, sir.
Okay, and why hydrogen is electron deficient?
It has
They
no
don't have
electrons.
electrons.
It has no electron. It has no electron, so it means that this particular species is electron deficient species. So when the ammonia was sharing its electron, it formed ammonium ion. It formed ammonium ion. So one more thing, this now what exactly happened? This positive attract the negative and they form NH4Cl. NH4Cl is known as ammonium chloride. Okay, tell me one thing. If I say this ammonium chloride contain all three type of bonding, so is this true or not?
True, sir.
How? How?
Sir, NH3 is
NH3 is
covalent.
covalent. Very
Covalent.
good. Very good. Next.
And
Coordinate.
NH4 plus Cl minus is
No,
ionic
NH4
bond.
and NH4 positive is coordinate
Coordinate.
and NH4Cl is ionic.
Ionic bond.
Clear? When it was in the form of NH3, it was covalent bond. It was when it formed NH4 positive and it was forming coordinate bond. When NH4Cl, it was forming ionic bond. Clear?
Yes,
Okay.
sir.
Let me take one more example of coordinate. Okay. When I'm reacting HCl with H2. Can anyone complete this reaction first? HCl plus H2. It will form H3O positive plus Cl negative. Okay. Now see what will happen. How this H3O positive is forming. HCl molecule will break into H positive and Cl negative. See, someone is creating sort of nuisance. See, if you are not, if you want to say something at that particular time, just open your mic. Rest time you can close it. Okay. So now you can directly see a water molecule have two lone pair. And in HCl molecule, I again break it into H positive and Cl negative. Now, which one is electron rich and which one is electron deficient?
H2O is the electron rich species.
Electron rich.
Electron rich species will be H2 and
H
electron
plus
deficient
is
species will be H positive.
Yes,
So now what will happen?
yes.
This H2O molecule donates its one lone pair to the hydrogen atom, and now they will form H3O positive. So H3O positive is again one example of coordinate bond. If I talk about the structure of the H3O positive, it will be like this. This is because oxygen is donating, sharing its one electron towards the hydrogen atom. Sharing electron. It is not a mutual sharing. Just because why I'll not say mutual sharing, this is because there is no contribution of the electron from the hydrogen atom towards the oxygen atom. Only the oxygen atom, which is electron rich here, this oxygen atom is sharing the electron to the hydrogen. So that's why I'm saying that it is not a mutual sharing, it is a sharing just. Have you got idea about the coordinate now?
Yes, sir.
Any doubt in coordinate right now? You can ask. Ask if you want. Or else I'll go deeper in the ionic bonding now. So just because I took this class just to clear the doubts of what is ionic, what is covalent, what is coordinate. So this was my topic just because I want to know that ionic, covalent, coordinate. Okay, fast, quick revision, just basics question I'm asking. Okay, you have to answer fast. Ionic bonding, also known as
Electrovalent bond.
what else? One more. One more.
Electrostatic bond.
For
Electrostatic bond.
electrostatic bond.
Okay. Coordinate bond is also known as
Dative bond.
Dative bond.
dative bond.
Dative bond.
Okay. High electronegative difference is present in ionic, covalent, coordinate.
Ionic.
Ionic. Okay. Polar and non-polar. What is the difference? The question is, in which type of bonding there is a partial sharing of the electron? You can say, or you not partial sharing. You can say, in which type of bonding there is a you can say unequal distribution of the electron. Polar or non-polar?
Coordinate, sir.
Unequal distribution. Polar,
Polar.
non-polar. Polar. Why?
Polar.
Why? Fast.
Because
Why?
of difference of electronegativity.
Mutual sharing.
Because of the difference in the electronegative between the atoms. Okay. H2O, which type of bonding?
Covalent, sir.
Covalent.
Covalent. How many lone pair are present in the ammonia molecule?
One, sir. One.
Okay. How many lone pair are present in the water molecule?
Two.
Two, sir.
Two, sir.
Okay, if I talk about the KCl, which type of bonding?
Ionic, sir.
Ionic. Just because potassium is the metal, chlorine is the non-metal. Metal and non-metal transfer of electron, that is known as what? Ionic bonding.
Ionic
Okay.
bond.
Okay. One more question. Okay. Examples. Okay. Fluorine. Just tell me MgF2. Ionic covalent coordinate. Mgf2,
Sir,
magnesium.
ionic.
Ionic,
Sir,
sir.
ionic.
Fluorine is the highest
Ionic.
electronegative element. Okay.
Ionic.
Okay. What is okay? The question is now. I'll ask one more question. That let me see a question right now. Okay. Just tell me what is polarization? Okay, just leave. Let's go deeper in the book. Okay. Now you can see your book, and I'll start according to your book. Okay. What starting portion was the same thing. What are the ways of? Okay. Now you will answer. Okay, I'll not answer. Now you have to answer. What are the ways for bonding? First ways of
Ionic covalent.
Ionic.
nahi, donating
Duplet.
and sharing. Donating contain
Yes, sir.
ionic bonding. Sharing contain
Covalent
Covalent and coordinate.
and
Coordination.
covalent and coordinate bond. Okay. So second thing, what is mentioned in your book? That is Lewis symbol. What is Lewis symbol?
dot
Dot and
Dot
Lewis dot
structure.
structure.
What it represent? What it represent? Lewis dot structure. What it
Atom,
represent?
valence
atom
Valence
electron.
shell. Valence
Valence electrons. Okay.
electrons. Yes.
What is the valency of chlorine?
7. Oh,
Sir.
seven.
Valency.
One,
Valency.
sir.
One, sir.
1, sir. 1.
-1. Okay. Just tell me a quick difference between univalent, bivalent, trivalent. First, what is univalent?
One electron in valence.
1. Valence
One,
is 1.
One valency, sir.
yeah, valency is one. You will not say valence is one electron in the valence shell. Valency is one. Valency when two, it is known as bivalence. Valency is three, that is known as trivalent ion. Okay. Okay. Give me example of trivalent. First,
Nitrogen, sir.
Aluminium.
Sir, aluminium.
aluminium. Okay. Al3 positive. Good.
Yes.
Okay. Next thing is one more type of two more type of bonding is mentioned in your book, that is hydrogen bond and hydrogen bonding and metallic bonding. So metallic bonding is quite easy. We'll go for that in more deep. But what exactly the metallic bonding is? When the two electropositive element. What are why metal are known as electropositive? Just because they have the tendency to donate its electron more easily as compared to the non-metal. So,
Non-metals.
yeah, when electropositive and electropositive element, they both are combining, they are forming a bond. That bond is known as metallic bonding. We'll go for that. But if I talk about hydrogen bond, what is hydrogen bond? Anyone can tell me that? It's a sort of attraction, you can say. There's a attraction between the hydrogen and the electronegative element. So I'll give you one shortcut. You can use only the FON, fluorine, oxygen, nitrogen. Okay, if fluorine, oxygen, nitrogen, no, it's not a trick. You can say it's a simply identification whether the compound will show hydrogen bonding or not. So if any compound contain fluorine, oxygen, and nitrogen, and also contain the hydrogen atom, if it contain both things, then there's a possibility that it can form the hydrogen. For example, I'm talking about the HF molecule. Another HF molecule, another HF molecule. Now this hydrogen will start attracting this fluorine will start attracting that hydrogen. So this sort of bonding is known as hydrogen bonding. We'll go for the types also, but just for recognize whether the compound will show hydrogen bonding or not, you can use this thing, that FON, fluorine, oxygen, and nitrogen. Okay, will this water molecule show hydrogen bonding? Will this water molecule show hydrogen bonding?
Yes,
Yes.
sir.
Why? Because oxygen is present. So oxygen will get attracted by the other hydrogen atom. Okay. Okay. If I talk about HCl,
No, sir.
No, sir.
no, just because it don't have fluorine, oxygen, and nitrogen. Okay. So these were the terms. So that I'm defining the terms only. I'll go more deep from the next class. So if you say the nature of bond is given in the book, that is electropositive element, when they combine electropositive, they form metallic bond.
Metallic
When
bond.
electropositive and electronegative will combine, they will form ionic bond. When electronegative and electronegative combine, they form covalent bond.
Covalent.
So these are the three type of bonding, and the fourth type what I taught you, that was coordinate bond. Okay. What are the factors for formation of ionic bond? Tell me.
Donating electrons.
Pardon? Again. Pardon? What have you said? What are the criteria? What are the condition for ionic bonding? Why, when ionic bond can form?
So to get stable.
Should have
No.
metal and another metal.
First condition is electronegative difference.
Force of attraction.
No, first condition electronegative difference.
Electricity.
Second, see, more easily the cation form, more faster the bond will form. Am I right? More easily the cation will form, more faster will be the bond. It means the ionization energy of the metal must be less, and ionization energy of non-metal must be more, or you can say electron. Okay, first let me clear this thing also. Okay, just because they are the basics, I'm going with the all basic whatever I'm saying. Metal was donating electron, so it was becoming electropositive. So it means more faster this metal form the cation, more faster the bond formation take place. If there is a problem in forming, or it will take more time to donate the electron, it means it is not trying to, it will not form simply the ionic bonding. It will try to prefer the covalent bonding. It will try to prefer another type of bonding, but not the ionic bonding. Okay, so remember this thing: electronegative difference, more easily cation form, more faster will be the bond formation. Ionization energy of the metal must be less, and ionization energy of non-metal must be more, so that then they can easily attract the electrons. Or you can say electronegative, or you can remove this point, or you can say electronegativity of non-metal must be more. Okay, what is the difference between electronegativity and electron gain enthalpy? What is the difference between electronegativity and electron gain enthalpy?
Sir, electron gain
What?
enthalpy is the
Yeah.
energy
Hmm.
required to give an electron to the atom.
To
And
give an
electronegativity. Yes, sir,
see,
to give an
to give away the electron. No? Okay, so this is one atom, this is another atom. I'm talking about one is giving the electron, another one is taking the electron. So in this giving electron, the energy will release, but in this particular thing, energy will be, okay, wait. In this particular, we need energy to be given, and in this case, energy will be released. So if the energy is given, then that is ionization energy, and if energy will be released, that is electron gain enthalpy. or electron affinity, you can say.
Yes, sir.
Okay, so it means whenever there is a removal of the electron from the outermost shell, that it means I'm talking about the ionization energy. But if I'm saying about the when the electron is added in the outermost isolated gaseous atom, that is known as electron gain enthalpy. Okay, so these are the conditions. Let's come to the other points. That is, metal always form cation or anion,
Cation.
and non-metal always form
Anion.
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 Okay, what is electrovalency? See, electrovalency is number of electron gain or lose. For example, I was talking about NaCl molecule, Na positive and Cl negative. They both were attracting by the electrostatic force of attraction. So if this Na positive is donating 1 electron and Cl is accepting 1 electron, so electrovalency is 1. Okay, if I talk about this CaCl2 or CaO, the example I've taken, CaO, calcium was donating 2 electron, oxygen was taking 2 electron. So the electrovalency is 2. So it means the number of electron donated or you can say accepted while forming the electrovalent bond or ionic bond, that is known as what? Electrovalency. Clear? Clear? Students?
Sir, can you repeat once again?
Once again, okay. Electrovalency means number of electron lose or gain. Well, I was forming NaCl now. Basic example. Atomic number of Na was 281. Cl atomic number was 287. So it will try to donate 1 electron, it will become Na positive. So how many electrons it is donating? 1. So its electrovalency will be 1. If Cl is taking 1 electron, accepting 1 electron, it will become Cl negative. How many electron it is? This Cl is accepting 1. So its electrovalency will be considered as 1. Now clear?
Yes, sir.
So just remember the number of electron gain or lose while forming the electrovalent bond. That is known as what? Electrovalency. And what is covalency? What is covalency? Number of electron shared. For example, Cl, single bond Cl. What is the covalency?
1,
1. Okay. What is the covalency?
3.
3.
3. Okay,
3.
good. So it means electrovalency is the number of electrons shared, or electron donated or gained, while covalence is the number of electron shared between the two non-metals. Okay, what are the characteristics of ionic bond? First, they are usually solid in nature. Just because the attraction force between the metal and non-metal is that much, they are generally don't have gap between them, so they are generally solid in nature. Second thing, they have high melting and boiling point. Okay, so just remember one thing: if attraction is more, then more energy is required to break the bond. If more energy is required to break the bond, it means the melting and boiling point will rise. Okay, so if there is a more attraction between the species, it means more energy is required to break the bond. For example, you can basically think that you two friends are there and there's a good bonding between you guys, and if anyone want to break your friendship, it means more energy he or she required to break that bond. So they obviously the melting and boiling point will rise. Second thing, they are generally polar in nature. Why they are polar in nature? Just because there is a highly electronegative difference between them. If electronegative difference is not present, they are considered as non-polar. Just because I was talking about NaCl, basic example, Na positive, Cl negative. Cl is in group 17 and this is in group 1. So there's a high electronegative difference between group 1 and 17. So it means they are generally polar in nature. Next one is they are bad conductor in solid state but are good conductor in the molten state. See, in the molten state, in the molten form, the ions are free to move. The ions are free to move, and when there are ions free to move, it means the conduction will be there. It means they will conduct electricity. They are considered as, at that particular time, they are considered as electrolyte. Next one is they are non-directional in nature because of not having any specific shape. They undergo ionic reaction very fast. They are really generally hard metals. So that is not a like you can say more tough part, just because this chapter is the chemical bonding, and chemical bonding have ton of things. Okay, so I was talking about only the characteristics. So attraction is more, so melting boiling point is more, polar covalent compound just because electronegative difference. In the molten form, the ions are free to move, so they are considered as electrolyte and they do conduction. So these are the main point in this characteristics. If any conduction, any characteristic you want to ask, we can ask right now. Anyone? Any characteristic you want to ask? There's a rule in chemistry, that is like dissolve like. Can anyone tell me what is the meaning of this? Anyone? Like dissolve like. Anyone know? No one?
No, sir.
Okay. So this rule means polar solute will dissolve in polar solvent and non-polar solute will dissolve in non-polar solvent. It means those solute which are polar in nature, they will always dissolve in the polar solvent, while the non-polar solute will always dissolve in the non-polar solvent. So this is the like dissolve like. So the one more characteristic that the ionic compound are dissolved in the polar solvent. Any of the polar solvent, that is basic polar solvent, we can take as water. Water is not considered as a universal solvent. So water is the thing which will get dissolved in the water. They will not dissolve in the organic compounds, just because organic compounds are non-polar in nature. While the things which will dissolve in the organic compound, they will not dissolve in the water, just because they are non-polar. So if you like someone's company, you try to sit with that particular person, you try to talk with that particular person. Same way, like in chemistry, like dissolve like means the polar solute always dissolve in the polar solvent, while the non-polar solute will dissolve in the non-polar solvent. Now clear?
Yes, sir.
Remember this is important. Literally, this is important just because it will come in your like 12th, like 12th and 11th. Every time whenever you learn this thing now. So if you'll ask that CCl4, just example CCl4, I was talking about that. Okay, basic example, I'm taking NaCl. NaCl will dissolve in the toluene? No, because NaCl is polar in nature and toluene is non-polar in nature. Basic question. So polar will not dissolve in the non-polar, so this will not happen. But if I want to dissolve in water, it will happen, just because water is polar, non-polar? Polar. Okay. Any question from any of the topic? No question?
No, sir.
Okay. That's it for today. If you want to ask anything, you can ask me right now. If you don't want to ask, then it's okay. And that's it for today from my side. I'll take another class on Monday, and I'll start with the ionic bonding, and we'll go more deeper example. We'll have lattice enthalpy. We will have Born-Haber cycle. Ever heard about Born-Haber cycle?
No, sir.
No, sir.
So that is that is important. Okay, so we'll go for the Born-Haber cycle. We'll go for another things. So see you on Monday. Okay.
Okay, sir. Thank you.
Yes, sir.
Have a good day.
Sir, thank you so much.
Most welcome, sir.
All right, students, join in the next session.